Distinguished Professor, thank you for your time. I am Xu Miaohan, and today I am honored to present my research titled Research on Commodity Sales Prediction Based on Sentimental Analysis, taking shopping user reviews and transaction data as an example. This work is part of Master of Business Analytics program. My research combined two key areas: customers review analysis and sales forecasting, aiming to bring more dynamic insight into e-commerce decision-making. Let me start with the abstract of my study. The purpose of this research is to investigate how sentimental analysis, derived from shopping user reviews, can enhance the accuracy of e-commerce sales prediction models. I used a hybrid modeling approaches that integrated textual features like sentimental polarity, extracted use text blob, along with structured data such as price discounts and historical sales. I trained the tested three models: random forest, ChargeBoost, and SVR, and discovered that ChargeBoost offered the best balance between performance and interpretability. The findings show that well-structured features still dominate sentiment, its value behavior context to enhance sales prediction. Traditional forecasting in e-commerce usually relies only on structured variables, such as product price, discount rate, or historical sales value. However, this often ignores an essential factor: customers' opinions and emotions embedded in their reviews. This oversight creates three core challenges: a lack of timely feedback from real users, over-reliance on static indicators, and missed opportunities for deeper insights. By integrating sentimental data, I aim to make forecasting models more intuitive and responsive to consumer behavior in real time. To address these issues, I set out with 5 specific goals: extract sentiment scores from Shopee reviews using the text blob label. Combine these sentiments besides variables with structured attributes like price and discount to building hybrid features. Training and compare the performance of 3 machine learning models: random forest, ChargeBoost, and SVR. Evaluate their accuracy using R-squared, mean absolute error, and evaluate their accuracy using R-squared, MAE, and RMSE. Finally, analyze how much influence sentiment features have in predicting product sales. Here is an overview of my methodology. I began by collecting Shopee product listings and review data from Kaggle. I cleaned and prepared the review text by removing emoji, non-English characters, symbols, and unnecessary space, and then extracted sentiment scores using text blob. In addition to sentiment polarity, I also created 2 more text besides features: review length and keyword count. These were then combined with structured data such as price, discount rate, and historical sales to build a comprehensive dataset. I trained 3 different models and tested them using standard regression evaluation matrix. After cleaning, I retained 3,892 valid samples. Structured variables included price, discounts, historical sales. Text-based variables included sentimental score, review length, keyword count. Interestingly, the sentiment scores range from -1 to +1, and most values skewed towards the positive side, indicating a general trend of high customer satisfaction on the platform. Over 18% of reviews received 5-star ratings. While this appears encouraging, it also reveals a limitation. Star ratings lack details. For example, 2 5-star reviews might carry very different emotion tones, which can't be captured by star alone. This is why I believe sentimental scoring provides a more nuanced understanding of customers' feedback. It captures several emotion cues that numeric ratings cannot. I trained 3 regression models, random forest, a Bayesian Bayesian ensemble that provides a strong baseline. Charge Boost, a boosting model known for high accuracy and good generalization. SVR, which is powerful on small clean datasets. All 3 models use the same hybrid features to ensure file compression. I also conducted cross-validation to reduce the risk of overfitting. Here are the performance results. Charge Boost achieved the highest square value of 0.9904, making it the best performing model. Random Forest also performed well, with only slightly lower metrics. On the other hand, SVR showed very poor results, including a negative R-square. This could due to the SVR model's sensitivity to skewed feature and lack of scaling. This highlights the advantage of ensemble models in handling complex and non-linear data in e-commerce setting. Next, I analyzed which features were most important to the models. Unsurprisingly, price and discount was the top predictor of sales. However, review length also ranked high. It reflects user engagement and emotional investment. Sentiment score came in fourth, just above keyword count. While it is not the strongest predictor, sentiment does contribute additional explanatory power, particularly when it's interpreting customer behavior. To summarize, this study demonstrates that a hybrid model which combines structured data and sentiment analysis outperforms models that rely on structured data alone. Among all models, Charge Boost showed the best results. Although sentiment features playing a supporting role, they improve model interpretability and responsiveness to customers' feedback. This approach allows business to better understand not just what customers buy, but why they buy it. In practical terms, this study has 2 key implications. E-commerce sales can monitor sentiment trends to adjust marketing or pricing strategies in real time. Encouraging detailed customers' reviews can generate richer data for feature analysis. For feature work, I plan to incorporate time series components to capture dynamic changes in customer sentiment and sales. Use more advanced NLP models like BERT to capture context better. expand the model across different product categories and languages to enhance generalizability. Thank you for your listening.